Solving little equations. Again, nothing new here. You should know how to do all of these. But we'll review a few things, and hopefully we're okay. Let's jump in at number 6. By the way, they're all solved for x. So always trying to get x by itself.
And 12, there's not an x. Oh, wait, but there's new.
Well, there's new information, yeah. Sorry, so I said that wrong. 1 through 9 solve for x. Number 6, there's maybe 2 different ways to do that. One way I think is more efficient than the other, but tell me, what would you do first on number 6 to start to get x by itself? I would multiply each side by 5 over 2. Some people might distribute, but then you're just going to have to fix that 2/5 later. So you might as well fix the 2/5 now and start to peel off the layers to get to x. So we multiply the left by 5 over 2, that cancels the 2/5, and we're left with x plus 1. On the other side, we'd have 5g over 2. Well, I think that just got a lot easier. What should we do next to solve for x? Let's subtract 1 and 5g over 2 minus 1. Thank you. Okay, so again, this is supposed to be easy stuff, but we'll see. It's good review. It's good practice. Number 7. Maybe a little tricky about number 7 is that there are 2 x's. We should get them on the same side. We definitely should. So I'm going to subtract the dx over, and I'm going to subtract the a over. All right, we okay with doing 2 things at once there? Okay, they're on the same side, but now what? How do I combine them? What would you do if you had 9x minus 7x? What's that equal to?
2x.
How'd you do that?
You just subtract that. You gotta make them like.
Yeah, you sort of held the x to the side and did 9 minus 7. Well, this isn't 9 and 7, but we can do that same thing. We can sort of hold the x to the side and subtract b minus d. Now, mathematically what we did is we factored out the x, and that left b minus d. And that's what you do with 9x minus 7x. You just never show it. Nobody ever says, factor out the x, 9 minus 7 is 2. Like, you just do it. Most of you probably aren't to that stage here, but it's the same thing. Hold the x to the side and then b minus d. And I want to get x by itself, so what should we do, Jack? Divide by b minus d. C minus a over b minus d. This is just good algebra practice, moving things around. Stuff you need all the time in physics and chemistry and pre-cal and calculus, all the algebra things. I hope that was a joke. Number 8 looks like a tough one. I hope not. How about let's skip to number 12. Solve all of that for h. So let's locate the h first.
It's next to the r.
It's next to the r. That's why we say solve for h rather than find h, right? You've seen the joke, find h. There it is, right there, found it. No, that's not what we're doing. We're getting h by itself. So let's pick on people here. I think this is I should never say an easy one and then call on somebody because that puts them on the spot. But we can put Nicole on the spot. She's good. What should we do first to get h by itself? I want to start peeling the layers off to get h by itself. So let's get rid of this guy first. Move him out of the way. So how could I get all of this to the other side?
2 pi r squared.
What do I do with the 2 pi r squared? Yeah, it's being added, so if I want to undo the adding, let's subtract. So s minus 2 pi r squared equals 2 pi r h. Again, we're trying to peel off the layers to get h by itself. Cooper, what do you want to do next to get h by itself?
I just divided by 2 pi r.
I like that. 2 pi r h is all multiplied together, so if we want to undo that, let's divide by 2 pi r. So h equals s minus 2 pi r squared over 2 pi r. Why are you not allowed to cancel? Yes, because we cancel factors, not terms. Still have that thing. Although, let me show you something from calculus that made the math department group me, including my comment on it. Right? 2y minus 6 over 3y minus 6? Yeah, you should shake your head at that. Come on, you can't cancel those 6's because those are terms. We can't cancel terms. We got to be multiplied by things. So yeah, no, please no, stop that. You're in calculus. Shouldn't be doing that anymore.
Who did that?
I can't tell you who did that. That would be a violation of their something. I don't know. It wouldn't be nice, for sure. It was someone in calculus, so it was not Cooper. Cooper would definitely not do that. Number 14. Oh, that looks tricky. 14. Trying to get r by itself. R has a cube on it, but I don't want to mess with that yet. What could I do to peel off the 4/3? Multiply by 3/4. That'll fix the 4/3. So 3v over 4 equals pi r cubed. Let's divide by pi. We're starting to just peel off the layers to start to get r by itself. So let's divide by pi. And I'm just going to put the pi in the bottom down there. I don't want it to look like 3v over 4 all over pi. That looks, it's not wrong, but it just looks terrible. It's not wrong, it just looks terrible. So just stick the pi in the bottom. That's what, if you'd rather say you're multiplying by 1 over pi, that might be an easier way to see that the pi just goes into the denominator. So 3v over 4 pi equals r cubed. And now we need to undo a cube, which would be a cube root. So we just cube root both sides, and r is the cube root of 3v over 4 pi. Again, absolutely nothing new today. Just practice on moving things around. Just the basic algebra skills of getting things right. Let's do 17. I'm not going to do the word problem for you. That'd be, leave the fun ones for you. 17. For t. We'll worry about 19 in a minute. It's just printed weird. But first, 17. I want to get t by itself. Yes, there's two options. You could distribute the p, but it'd probably be easier to divide by it because you want to get t by itself. So you may as well start sort of peeling off the layers to get. So a over p equals 1 plus rt. And then, what would you do next? Subtract the 1. would you like to do next? Divide by r, and that might look weird on the left-hand side. So if you don't want to divide by something, what could you multiply by? 1 over r, if that's easier to see that r goes into those denominators. So a over rp minus 1 over r equals t. I suppose you could get a common denominator and combine those, but it doesn't ask for that, so we solve for t, we're good. Oh, look at that, the notes I borrowed from Miss Craig from long ago. She distributed the p and then had to divide by it later. So it's fine either way. This answer looks a little different than ours, but if you got a common denominator, it would look the same. Who did it the harder way, me or Miss Craig?
Craig. It was not.
I mean, it wasn't that hard, but it's a different way for sure. Yes, 19 is a little weird just because it's over here, and there's two m's there, but you can handle that. Let's look at 19. Let's put it back where it belongs. Yeah. So I got to get m by itself, but there's two m's. So what about that 3?
We should distribute it.
Yeah, we should distribute it this time, because if I divide by it, I still have m's on both sides, and now I've got a fraction to mess with. So I suppose it could be worked by dividing by 3, but then that's going to be kind of ugly. So let's just distribute the 3 instead. Again, I'm still looking at the m's. I need to get all my m's on one side and all my not m's on one side. Which side do you want the m's to go to, the right or the left? Why the right? I agree, but that way it'll stay positive. Should work either way, but if you move them to the left, you got negative 5m. It's probably easier to work with positive 5m. So I'm with you. Let's move them to the right side. Makes life a little bit easier, I guess. All right, what next? Minus 3k. Negative 1 minus 3k equals 5m. And the left side's looking weird, but if I have 5m equals something, what do I do to get m by itself?
Just
Divide by 5. So negative 1 minus 3k over 5. If you'd have wrote, if you had written that differently, maybe you had negative 3k minus 1 over 5, but that's the same thing. All right, so just more practice on moving things around, and then to add to your fun, and because you have an extra day this week, is this next worksheet, property of exponents. Let's do the odds on that. That's definitely old stuff. But man, some of us still need some practice. So 2 assignments today, but I don't think either one of them is that difficult. The second worksheet is just odds. The first worksheet we did, well, not half of it, but a chunk of it.